Every day, Jack drives from home to work. Now when Jack goes at 40 kilometers per hour, he arrives 1 hour late. When Jack goes at 60 kilometers per hour, he arrives 1 hour early. And we want to find out at what speed Jack should be driving to arrive at work precisely on time. And no, the answer is not 50 kilometers per hour. So let's find out what it really is. So we're given some information on the rates and how these rates affect the times. If Jack goes at 40 kilometers per hour, arriving 1 hour late means he's spending 1 more hour on the road. If Jack goes at 60 kilometers per hour, arriving 1 hour early means that's 1 hour less on the road. And when we have rates and some times, then we can use this equation right here, D equals RT. So let's see how that works. So let's work with our first rate, 40 kilometers per hour means he arrives 1 hour late, which means he's spending 1 more hour on the road. Now let's say Jack's normal trip from his house to his work takes T hours. Well, if it usually takes T hours, going at 40 kilometers per hour means he will spend T plus 1 hours on the road. Now let's use our second piece of information. Our second rate is 60 kilometers per hour. Arriving 1 hour early means he's spending 1 hour less on the road. So he would be spending T minus 1 hours driving. Now both of these over here represent the distance between Jack's home and his work. These are rates and these are the times. So really, these two are equivalent to each other. And from here, we can solve for T. All we have to do is open this up. And we'll find that T equals 5. So Jack's work is 5 hours away from his house. And now that we've found T, we can plug this value of T back into any one of these to find the distance. You can choose either one, but I'm going to choose 40 times T plus 1, which is equal to 40 times 5 plus 1, which is 40 times 6. So we see that the distance between Jack's home and his work is 240 kilometers. So now that we have a time and we have a distance, now we can find the rate at which Jack should drive. The rate is just equal to the distance divided by the time, which is just 240 divided by 5, which gives 48 kilometers per hour. Now let's say we didn't like that first solution so much. Well, fortunately, there's another way to solve this problem. So in the first solution, we found the time first, plugged that time back in to get the distance, and then we found the rate. Well, in this solution, we're going to find the distance first, then we'll find the time, and then we'll use those to find the rate. This time, let's say the distance between Jack's home and work is d kilometers. And once again, let's say that the trip normally takes t hours. Then from our equation, d equals rt, we're going to arrange it for time, and to do that, we'll divide both sides by r, and we'll get t equals d over r. And once again, by the same logic, if Jack goes at 40 kilometers per hour, he arrives 1 hour late, which means he's spending 1 more hour driving on the road. So t plus 1 hours on the road is equal to the distance, which is d, divided by the rate, which is 40. Similarly, going at 60 kilometers per hour means Jack arrives 1 hour early, which is t minus 1 hours spent on the road. And this is equal to the distance, which is still d, over 60. Now remember, I said that we were going to find the distance first. But here we have t and d. So is there a way that we can get rid of the t somehow? Well, yes. We can get rid of the t by subtracting both equations. Because when we do that, we'll get t plus 1 minus t minus 1 equals d over 40 minus d over 60. And when we simplify this, the t's will cancel out, and we're just left with 2 equals d over 40 minus d over 60. And from here, all we have to do is simplify our fractions to find d. And we'll do that by multiplying both sides by the least common multiple of 40 and 60, which is 120. And when we do that, we'll find that 240 equals 3d minus 2d, which is the same as d. So that worked out very well. We found the distance between Jack's place and work is 240 kilometers. And now that we found our value of d, we can plug that into any one of these two to find the time. It doesn't really matter which one you pick, but let's say we go with t minus 1 equals d over 60, which is 240 over 60, which is 4. So once again, we'll find that t equals 5. So now that we found our distance of 240 kilometers and our time of 5 hours, then we can find the rate at which Jack needs to be driving to arrive on time. And the rate is just the distance divided by the time, which is once again 240 over 5, which is 48 kilometers per hour. So once again, Jack needs to drive at 48 kilometers per hour to arrive at work precisely on time. And since we got the same answer of 48 kilometers per hour two different ways, then we can be pretty confident that our answer is correct.